I decided to cut the last tutorial a bit short because it was running close to like an hour in total video length, minus all the cuts and editing. So I believe we last left off at the pulley assembly. So we're just going to pick right back up. So we're going to open up Solidworks. So we're going to import, well I already did this right here, but just insert the mechanism assembly into your drivetrain. So yeah, we have it right here. We're going to concentric mate this to our rec shaft. So we're going to select this and select the hole we made for the rec shaft. And then we're going to click concentric. So as we can see, this is aligned. Okay, so now that we've mated this here, we're going to create our other mechanism assembly. We're going to go to File, New, Assembly. Okay, so now we're going to grab our other mechanism. So if you chose the left mechanism last time, you're going to choose the right mechanism this side, and then vice versa. Got it right here. Okay, so this time we won't have to do all the like the making the holes for the lock nuts and stuff because we've already made those holes in the last one. So when we import this pulley, you can see the holes are right here. So we don't have to go through that process again. All right, so we're going to concentric mate this lock nut slot we made to the lock nut. So we're just going to select any curved edge on this lock nut, and then we're going to concentric it. And then now that we have it here, we're going to select the opposite side, and then made it to the opposite lock nut from the one we did last time. So as you can see right here, it's misaligned. So the surface where we normally want this surface we normally want it to be on the outside, it's on the inside. So what do? We do a concentric mate flip or concentric flip mate alignment. So we're gonna make, or actually we're gonna make this edge, this face over here, and then we're gonna go down to we're going to open up the pulley file, open up the mate folder, select the coincident mate, right click it, flip mate alignment, and there we go. It will show something like alignment of the following mates was reversed to prevent mate errors. You can just ignore this, select don't show again this session, and select no, and then you'll be good. Okay, so now that we're here, we'll get our bearings. I think at this point in the tutorial series, you should start to be able to do some stuff a bit faster because at this point we've done a lot. So yeah, just to give you an indication of how far we've been going. Okay, so yeah, we coincident mated the flange onto the pulley, and then we concentric mated the bearing into the pulley, and then now we're going to do this to the other side. Going to first concentric mate it. Gonna zoom in, select this face, select the other face, coincident that. I said before that you can like open up the folder and then open up the mate folder right here, but actually you can just go scroll to the very bottom and you'll see all of your mates regardless of what parts they affect. So you can just select your most recent one, which is obviously only if the most recent one is the one that you want to flip. Let's say the most we just coincident mated this, and it's the most recent mate we made. So and we want to flip this mate, so we just select the most recent one. There we go. It's much faster than last time. I'm gonna save this. Right mechanism assembly. Ignore my bad capitalization. Drivetrain tutorial assembly. There we go. We'll wait for this to save. There we go. Close out that. Close out this. Right. Oh, oops, this is not where I want to be. Alright, finally. Insert components. Browse. Right slant. Yeah, right mechanism assembly. There we go. So now we're going to do the same thing we did last time. select the inside of this bearing and the inside of this hole we created, and then there, concentric mate that right there. And then we're going to select the face of this pulley and coincident mate the face to the other pulley. Oh wait, oops, to the other pulley. And now there. So when we move one mechanism, the other one will follow it. So it just makes sure our mechanisms are perfectly aligned. So, all right. So now we're going to set. Okay. So right now we can move this mechanism assembly back and forth, but we kind of don't want that. So what we're going to do is we're going to create something called a spacer, which is a little 3D printed thing that fits around the shaft right here, and then that spaces the mechanism assembly away from the side plate. So let's say let's just measure how much it is right here. So we're going to select these faces, click the measure button, and as we can see, it's about 22 millimeters, or 21.78 if you want to be exact. 21.78 millimeters. So I guess maybe a 0.1 inch pulley. I mean, not pulley spacer would be good. So we're gonna go File, New, Part. Okay. We're gonna show our planes. Okay. So now we're going to make the spacer, and obviously our spacer has to have a hex bore so that it can actually fit onto the shaft. So we're going to go over here. We're going to select the polygon, and then we are going to. I'm going to start the sketch on the top plane. I'm going to center this right here, and then I'm just going to draw it. And then yeah. So as you can see in this polygon interface, we can change the amount of size we want. So if we want an octagon, we can do that. But we want a hexagon in this case because we're working with a Rex shaft. And then here's the size of the bore. So the shaft is 12 millimeters, but what you want to do is you want to subtract 1 from that, so that'll be 11 millimeters. And once you subtract 1 from that, that's the perfect bore size, and it'll fit onto your shaft just fine. So now we have our bore right here, but we obviously we want something around it. So want something surrounding it. So we'll just create a circle right here, and then we'll make this maybe 15 millimeters. Oh wait, no, not 15 millimeters, sorry. Maybe like 9 millimeters. There we go. Now we're going to do features extruded boss. So since we have two sketches right here, we can see SolidWorks automatically figures out that this hexagon, we're not trying to fill this in. This is going to be our bore, so it automatically just selects what surrounds the hexagon, which is really cool. And it's automatically set to 0.1 inches, which is cool as well. Okay, we have our spacer. Now we're going to save this. We're going to call this mechanism spacer left, or outer. I'm going to go to part, save it. I'm going to close out this, go back to our assembly, and then we're going to get our spacer in here. Alright, so we're going to take, now we're going to mate this onto the shaft, and normally we do a concentric mate, but this is a hexagon, so we're going to do some coincident. We're basically going to coincident mate the interior faces of the hexagon to the exterior faces of the shaft. So we're going to select this face maybe, and then this face. Coincident that, and there, you see these faces are lined up. Now we're going to go under, and then maybe just fetch this face. You can really just get any two faces. And then, but you have to make sure they lock onto the corresponding face. Otherwise, you're going to get an over-defined mate error, which just means you have too many mates. I did that a little fast. Next time, I'm gonna have to do it another time though, so I'll do it a bit slower the next time. We're gonna coincident mate the spacer to the interior of the outer drive plate, and then we're going to take this. We're going to select this spot of the bearing, and then mate that to the spacer. And there we go. We can't move this mechanism anymore. It can only spin. which is nice. Okay, so now we're going to do the second spacer. We're going to copy this. We're just going to select the spacer from the feature tree. That's the easiest way to do it, in my opinion. We're going to hit Control V to paste it back in. And now I'm going to do the same thing I did last time, but a bit slower. So it doesn't matter which faces you start out with. It really just matters the second face you do, because to lock a hexagon onto another hexagon, you need to do two mates. One mate that locks it from going this way, and then one mate that locks it from going this way, if that makes sense. And when you have those two axes locked, that locks the spacer onto the shaft. So the first one isn't a big deal, but the second one, you want to make sure it lines up with the one you did in the first place. Otherwise, that it will give you an error, because it won't be, you'll be breaking the geometry of the model. So we're just going to do the top face. We're going to take this out. Yeah. So now that we've made it the top face, we're just going to select the adjacent face to the one we did last time, which is, if you don't know what adjacent means, it means just directly across from, or not across from, directly next to. And then you're going to select the adjacent face to this face on the rec shaft that you made it in the first place, and then you're just going to coincident that, and there we go. It can only move that way. So now we've properly spaced out these two mechanism wheels. We'll have to make another spacer for this side later, but we'll do that in the future. So now that we have this, we have to power these wheels somehow, right? So for that, we need motors. And what we're actually going to do is we're going to do something. We're going to do a countersink. Like last time, we countersink the bearings by pushing the flange into the pulley. We're going to push the motors through this plate right here, which conserves a ton of space in the center that we can use for maybe an odometry module, or maybe some pulleys for a lift, or pretty much everything. Or not everything, anything. Now we're going to get our motors. So we're going to go back to gomoda.com. Let's exit out of these tabs. I'm going to go to motion. I'm going to go to motors. I'm going to go to yellow jacket, this one right here. And then we're going to select the 435 RPM, otherwise known as the 13.7 gear ratio. In FTC, you're going to want to say the gear ratio and not the RPM. So now we're going to select the step file, rinse and repeat. You guys should know how to do this by now. Okay, so now we have our motor. We're going to save this, and we're going to call it 13.7 to 1 yellow jacket. I'm going to go to documents, or wherever your file is, or your files are. Parts. Oh wait, no. Drivetrain tutorials, parts. Okay. Oh, actually, you can't use colons in your title, so you're gonna want to change this to, like, you might want to just spell out 2, 1. Okay. So now we've saved this. We're going to go into our assembly, insert components, browse. And then we're going to copy this, paste it. We want 2 motors because this is a 4-motor drivetrain. And then, well, actually, you can Control Z, by the way. If you press Control Z, that will undo your last action. Instead of doing that, you can click on this face, click on the other face, and we're actually going to parallel mate this. So that's parallel to the drive plate. And we're going to scroll down, and we're going to flip the mate alignment. Now we're going to select the motor, and now we're going to paste it. And this pastes it in the correct orientation this time. Okay, so now we have to create a cutout in our drivetrain for where the motors will go. We want to push the motors as far close to this wheel as possible, because that way we'll get like some space for our lateral, is it called a lateral? Our parallel odometry wheels. So we'll put this here. But you want to space these two motors apart a good amount because uh, our pulleys that we use, the 34 tooth pulleys, are pretty big, so you don't want them intercepting with each other. So before we do all this motor alignment stuff, we're going to open up our DXF file from before, the one, the 34 tooth one, and we're just going to make this into the pulley like we did last time. Import the part as a 2D sketch. We're going to select metric. Where is it? Oh wait, no, not metric, millimeters. And then select finish. Okay, features, extruded boss, rinse and repeat, same thing we did last time. 9.8 mm, check mark. Sketch, do a circle. Make this big. Let's set this at, I think 29 mm sounds good. Oh no, not 29, not 19 mm. 29 mm. 1 millimeter thick. And then extruded boss. Yep. Alright, so now we're going to create a circle right here. Oh, this is, we're gonna so to mount this pulley onto our motor shafts, this is where this pulley is going, by the way. It's going onto the motor shafts, and then this pulley will connect to the wheel pulley using a belt. Anyways, to connect this pulley to the motor shaft, we need something called a sonic hub, which is like this part with screw holes in it, in a shaft hole in it that will mount onto the shaft. So we're just going to create a pretty large hole for our sonic hub to be countersinked into. So we'll set this to like a 10 millimeters maybe. No, we'll do 20 millimeters. Yeah, that's good. Then we're gonna extruded cut. We're gonna cut in 9 millimeters probably. Yep. And then now we are going to make a hole in the center that is 7 millimeters large. And then we're just gonna cut through all. Or yeah, through all. And you can pause and go back if you missed that. I think I did that a bit too fast. Okay, now we're gonna save this. We're gonna call this 34 tooth pulley. We go to Drivetrain tutorial part. Save this. Okay, we have our pulley. Now we're going to close out some tabs. Make sure you're constantly closing out tabs you're not using, because that just makes Solidworks run a lot faster, and it's a lot easier to work when you don't have a ton of tabs opened up. It just clears your mind, you know. Now we're going to go back to GoGoda, and we're going to import a Sonic Hub. So we're going to go to Motion again. I feel like all the parts we've got today are motion based. Now we're going to select Hubs, Sonic, and then make sure you select Sonic Threaded, 6 mm D-bore, or 6 mm D-bore right here, the second one. We're going to click Step File, and then again we're going to import this just as we do every single time. We have our Sonic Hub loaded up. We're going to save it and call it Sonic Hub. Going to go to wherever we save our files. I know this is an assembly file, but like it's pretty small, so I just put it in parts. Okay, so now we're going to import our Sonic Hub and pulley. We're going to go to Browse, go to wherever you save them, select the pulley, and then hold down Control and then select the Sonic Hub. This will select both of them, and then that will import both of these files into your document. Okay, so you're going to want to select the inside circular part of this bore and select this hole right here and concentric mate them together. Now take this face. Make sure the face you select at this part is the face where this like circular part is jutting outwards, or where this circular part is. So we'll select this and select the inside of this pulley, and then I guess the mate menu isn't showing up for some reason, so I'm just going to manually deploy the mate menu. And then actually, while we're in this mate menu, we can actually flip mate alignment while we're making the mate, which is really cool. So yeah, so either way you do it, just make sure at the end um, you end up where the sonic hub is inside this little hole we created. Okay, so now we have to create holes into the pulley to mount onto the sonic hub. Everything you make in CAD, you have to put holes in it, especially if it's a custom part. You have to make sure you're able to mount it, because when you manufacture it, you don't want to be like drilling holes into it, because that's just going to consume a lot of your time. It's going to be really inaccurate. So we're going to right click this, edit the part, and now we're going to, same way we created holes last time, we're going to create holes in this pulley. So we're going to lock, we're going to get the circle tool, we're going to lock onto the center of this circle, and then we're going to type in 2 millimeters and there, and then we'll do it for the rest of the 3. 2 millimeters, 2 millimeters, 2 millimeters. Okay, so now we're going to click features and then extruded cut, and then we're going to go through all. And there we go, we have our holes. We're going to click the outside, the circular edge of this sonic hub hole, and then the interior edge of this pulley hole, and then we're going to concentric mate those. So now this thing right here is a perfectly fixed subassembly. Well, technically it's not a subassembly because it's not an assembly file, it's just files in an assembly, but they're mated together solidly. I guess that's how you'd put it. Okay, so now we're going to select the interior circular edge of the sonic hub, and then the circular edge of this motor shaft, and then we're going to concentric mate that. So we have this, and then now we're going to copy and paste, but make sure you select the sonic hub and the pulley. Copy that and paste this. And this time we won't have to mate these together because it might end up like somewhere here. So if you don't see it, just zoom out and you'll probably see it. We don't have to mate these together because as you can see, we copy pasted them and the sonic hub is following the pulley just fine. So we're going to do the same thing, select the interior edge, select the motor shaft. There. Well, that motor flew up there. We'll bring it back down to earth. There we go. So we're just going to position these in here just so we can get a rough idea of what we want. We're going to actually first we'll select the outside of this pulley and then once again mate it to, well, to make this easier, there's a feature in Solidworks. You can select a part and then hit tab on your keyboard and that'll actually hide the part so that you can work with it easier. It hasn't deleted the part, it just hid it. So when you want it back, you can just find it in the feature tree. You'll see it's like hollow instead of, as these ones are yellow, this one's white. So you just click this and then click on the eyeball and you can see it's back. So we're just gonna take this out and then we're gonna mate these together. It makes it a lot easier to work with. And then take this face, take the front face. Coincident. Oh, looks like we haven't properly mated this mechanism. Oh, and yeah, that's just a SolidWorks glitch. Sometimes it fails to keep up with like what's happening, especially if you have a low power CPU like mine. So even though you made it something, you'll see the thing go flying across the screen, but then when you just like move, like select it and move it, it'll just go back to normal. So that's nothing to worry about. Now we're gonna pull this motor back here, and we're gonna actually go up here, find the thing we hid before, and then unhide it. There we go. Yeah. Now what we're going to do is we're going to get the tip of this motor shaft and coincident mate it to the outside of this parallel plate, and then do the same thing for the other motor shaft. All right. So now we're just going to move these pulleys into a good spot. These aren't exactly where they'll be going, but just so we can get a frame of reference. Yeah, this looks good. So now we'll actually create holes for the motors to reside. First, we'll select this, right click, edit part, and now we'll select this line and then select the outer face of this parallel plate. Now you're going to anchor your line onto this hole right here on the drive plate, and then just extend this out. And then now you're going to put it at like approximately, you're going to pull out your smart dimension tool, and then you're going to put it at like 3.6. Oh wait, actually, hold on one second. 3.6. We might want to do this in millimeters actually, because when we create belts, it will make it a lot easier. Okay, so 91.44. We're gonna set this at 91.44 millimeters. Okay, there. So now we're gonna create another line that goes over here. We're just gonna you can just drag this out here first, because when you try to put it over to that shaft, it's going to try locking onto it, which is going to be a bit annoying. So now you can dimension this, and you can set it to 3 inches. Or actually set it to 2.5. There we go. So 2.5 inches and 3.6 inches. Now we're going to create circles at the intersection between those two lines, right here. And then we're going to set this at 7 millimeters. And then we'll put another circle at the end of the second line, and also put that at 7 millimeters. Now we're going to go to features, extruded cut. I'm going to select both of these circles. My bad. Through all, check mark. There we go. All right, so now we have some circles to anchor our motors onto. We're going to select any rounded edge on our motor. So I'm just going to select this one, and then the hole we just created, and then concentric mate those two. We're just going to check if these, yeah, they're spaced properly. Okay, and then we're going to do it for the other one. Great. All right, so you can see it's going already. As we can see, there's a collision right here between the plate and the motor. So we're going to have to make a hole in this plate, in this inside plate, so that it can, there's no collision. So if you remember all the way back to when we created these plates, I said that we need to create 2 different plates because they're going to be different. Here's where the differences start coming in, because here, this hole is going to be a lot smaller than we want over here, because this one's going to be for a bearing, a small little bearing. This one's going to be the entirety of this motor. So this is where the differences start settling in. We're going to right click this parallel plate, edit part. We're going to lock onto the center of this motor. Should be right here. And then you can just put it at any size for now, and you can draw your second circle. Okay, so you can set this at any size, but what you're going to do now is you're going to click this circle, and then you're going to click this rim right here. Make sure it's this rim, and then click cordial, and there you go. And then do the same for this. Oh, oops. Make sure you don't select the face, because that won't work. There we go. Now we're going to extruded cut. Well, actually, to be on the safe side, we might actually want to make these holes a little bigger than the motor itself, because that'll just make sure everything runs smoothly. Because you don't want to be like inserting your motor into the drive plate and it just like doesn't budge. So you're gonna right click that sketch and click edit sketch. Now you're gonna click on the circle, and you're gonna go here, right click, delete all. Now you're going to set this to 0.8, and then you're going to do the same over here. Set this to 0.8. There you go. Now you're just gonna click edit, exit sketch, and there you go. Your motors are a bit, or your holes are a bit bigger. Next order of business, we're gonna get two smaller bearings and insert them into these two smaller holes. And this is because it will offset the stress overload on the motors, because when you have your shaft like without any support, your motor shaft without any support, it could be susceptible to breaking under pressure. So we're just gonna get that bearing, and that will reinforce our shaft. We're gonna click on motion, bearings, flanged, and then we're going to go to 6mm inside dimension, 14mm outer dimension, and we're going to click step file. Same procedure, import a step file. Okay, so we have our bearing. We're going to not run import diagnostics. Click save. I'm going to call this 6mm bearing. I'm going to exit out of this. Close this window. Now we're going to insert that bearing. Okay, so now we're going to concentric make this in. Except, as you can see, this flange is facing on the outside, but we want to make it face on the inside. So we're going to select this face, made it right here, flip mate alignment, there we go. Now we're going to select this bearing again, select it, Control C, Control V, concentric mate this into the hole. And then coincident mate this onto the plate. Yeah, so we have a bit of room here between the bearing and the pulley. We'll need to make another spacer here to just make sure the bearing doesn't fall out. Okay, so we have this. Now we need to secure these motors in place, and we do this with like a little, we're going to make a smaller version of like this plate, and that will hold these motors on. So it'll be about 1/8 of an inch thick. So we'll do File, New Part, show our planes, and we're going to make a rectangle right here. So we're gonna, well actually let's go back to our assembly. We're going to measure, click evaluate, measure, and then what you're going to do here is you're going to select this line right here, and basically just select the outer bounds of these motors, so we can just get a bit of an estimate of how far how long this plate needs to be. So it's like 85mm, it shows 85mm right here, so maybe we'll set this to like a 90mm or maybe 92mm wide plate. We'll go 92mm, and our drive plate is about 100 or 80mm tall, so maybe we'll make this 60mm tall. Or no, we can shrink this down to 50mm, and then we'll do extruded boss slash base, and then 1/8 of an inch. Now we're just well, we're gonna slap some chamfers on the sides of it. But before we do that, we're just going to import this into our assembly just to make sure everything's running well. We're going to call this motor plate. We're going to save it. Don't close out of the window yet because we'll need this later. Insert components and motor plate. It showed up for me right there, but it might not for you. Coincident mate the inside of this motor plate to the outer face of this motor. And we're just gonna Okay, yeah, so we see there's some issues right here. This is not nearly wide enough. We need to have space on either side of these, either side, either side of this motor. So we'll click on this space right here, and then right click and click Edit Sketch, or yeah, Edit Sketch. Now we're going to select this dimension we made here, and then we're going to set this instead of 90 millimeters, we'll make it maybe 110 millimeters. Yeah, that should be good. Gonna click Edit, Exit Sketch. We're gonna go out of Edit Component. Yeah, that's about right. Now we're going to go back to our motor plate right here. Okay, now that we're here, we're going to create some lines. One down the middle, again, anchor this to the center point, go down to the bottom, and then one horizontally. Okay, so now we'll make a line here, and then make another line. Basically, just divide this line in two, and then we're gonna right-click this large line, and then delete this. There we go. Now align this to the center, and this will be about, what is it, 7 millimeters. And now we're going to extruded cut. Okay, so now we're going to take that hole we made earlier, this one right here, and then we're going to get any circular face on the motor and concentric mate. So as you can see here, it's not really centered. There's some stuff off to the left, off to the right. So we're going to have to change the position of where this hole is. So open this up, right click, edit sketch. Now we'll delete these two lines. And we'll align this line right here, and then we'll lock this at the center of this circle, and then we're going to do some smart dimensioning. So right now this is 1.8, we'll put this at 0.75. This is a bit trial and error-y, but yeah. We have to go, we went a little too far. Yeah. There's a bit of trial and error aspect to this, but you'll get it eventually. Yeah, that's about right. So now that we have that right here, we're going to hide a couple things. We're going to click tab on this drive plate, click tab on this pulley, and click tab on the other pulley. And then also on this sonic hub, these screws, and that's it. Now we're going to click edit part, or edit sketch. We're going to get our circle and align this to the center of this bearing right here. Yeah, right there. 7 millimeters. Exit sketch. There we go. So now we can go back to everything we hid. So we'll bring this back. Just unhide everything you hid before. For the sonic hubs, you'll see the things you hid on the sonic hubs will actually be deep in the sonic hub folder since it's an assembly, so take note of that. Show that, and there should be, yep, one more pulley. There we go. Now we're going to just make this plate look a bit nicer by putting some chamfers on it, or some fillets, I mean. Oh, oops, wrong one. So you're going to click these 4 edges. And then we're going to set this at 0.2. Check. There we go. We're gonna save this, and then well, actually before we're done here, we'll make some sketches. Or oops, get your circle and then click on this outer bound, and then you'll see something show up here. You're gonna make a circle there, type in 2 millimeters, and then there. This is where we'll mount the motor plate onto the drive plate. I'm gonna do it for the rest of them as well. Feel free to pause the video if you need to keep up. Features, extruded cut. Yep. Okay, there we go. Well, actually, one last thing. We'll make a couple more holes because we just want to make sure this plate is very secure, because this is where our pretty much the most important part, or the heaviest part of your drivetrain is, which is the motors. So you just want to make sure these are very resilient. So you want to get the center of these holes, and then line this up to the center of this plate. Yep. And 2 millimeters. Oh wait, oops, I messed up. If you mess up, you can just drag the circle around and you can just line it up like that. No big deal. Features, extruded cut. There we go. So this plate is finally done. We'll exit out of this. Yeah, so now we have to get a measurement. We're going to get a quick measurement right here. I'm going to select this face, evaluate, and measure. So this is 51.175 millimeters. What we're going to do is we are going to get a 50 millimeter standoff. What a standoff is like a circular rod, and that basically just allows us to screw this plate from all the way over here into there. We're going to get a 50 millimeter standoff, and then we're going to make a little spacer that will space it out to the correct distance we want. So we're going to go to goboda.com again. Oh, oops, wrong tab. Goboda. This time we're going to click on structure. We're finally out of the motion section. We're going to click on shafting and oh wait, no, my bad. We're going to go back. We're going to click on standoffs and spacers, bottom left. M4 standoffs. And then go down here, 50 millimeter length, and import this file. Once again, we're just importing a file. We have our 50 mm standoff. I chose not to import diagnostics again. I'm going to save it, call it 50 mm standoff, save it wherever, design. Next, this. We're going to go back to our drivetrain file. We're going to go to assembly, insert components, browse. We're going to fetch our standoff. So we're going to take this and we're going to select the outer rim of the standoff and select this hole right here. And then we're going to concentric mate these together. And then we're going to coincide this space to the other side. Now you can see there's a bit of space in between because it's not a perfect fit, so we're just going to make a little thing that goes in between that will space it out properly. We're going to get a measurement 1.175 millimeters. So we need to make a 1.175 millimeter standoff, or not standoff, spacer. We're going to go new part, show our planes, sketch. This time we don't need to make an hexagon. So it's oh yeah, so we're going to set this 2 millimeters and then bring this out. We're going to set this to 3 millimeters because that's the outer dimension size of the standoff, so that everything's just nice and flush. We're going to click extruded boss / base and then 1.175 millimeters, the measurement we got before. And then we can do a little fill around here just to make sure it like matches aesthetically with standoff. Select this, put this at 0.1 millimeter. Yeah, seems weird. 0.1 millimeter radius. What's the point? Whatever. Okay, we're gonna call this standoff spacer. we're going to insert the standoff spacer in here. Oop, another Microsoft Teams email, not email, notification. Okay, standoff spacer. Got this right here. We're going to concentric mate the interior to the standoff. And then, oh wait, this is moving. That's not good. Oh yeah, we forgot to you have to do 2 concentric mates on this motor plate, so we'll just make this over here. There we go, problem fixed. Yeah, so now we're gonna coincident mate the spacer to the plate, and there we go. It's a nice little combination. Well, actually, instead of coincident mating it to the plate, we're actually going to drag this out. I undid it over there if you're wondering why. We're going to select this interior, and then we're going to select the outerior here, and coincident mate that together. And the reason we're doing this is that when we copy paste this, it will be properly mated together. So we're going to select these two. Oh, oops. Nope, nope. Okay, select these two, Control C, Control V. It's not here, but if we zoom out, we see there's a shadow. I have legitimately no clue why it always ends up there, but whatever. But at least it shows that, yeah, so this spacer and the standoff stick together, that's cool. Now we're going to click, we're basically just going to repeat this process for all the holes on this side. Click that, and there. We're going to paste again. We're just going to paste 4 of these in here. Did they end up there again? Or, yep. Just like that. Over here. Concentric mate. Coincident. And then later we'll make holes on the drive plate to secure the standoffs onto it. Can you get this? Okay, cool, last one. So yeah, so now we've properly secured, as you can see, it's pretty heavy duty. Nice. Alright, so yeah, like I mentioned before, we need a spacer over here just to make sure this bearing doesn't pop out. So we're going to get a measurement here between this bearing and that wall. So that's 5.16 millimeters. So we're going to make a 5.16 millimeter spacer, hex spacer. Shoulder planes, polygon, top plane. We're going to 11 millimeters, and then we'll make a circle out of here and set this to 15 millimeters, or not 15 millimeters, 10 millimeters. Now we're going to features, extruded box flash face, and then 5.16 millimeters. That was the memory there. I almost forgot what the measurement was. Okay. We'll name this mechanism spacer to, actually mechanism spacer inner, sorry. Exit out. Okay, so now we've created our spacer, we'll insert that. Browse. Inner, yeah. Well, there's actually an easier way we can do it from last time. We're going to select the outer thing right here, and then we're going to select the inside circle. We're going to concentric mate this, and then to secure it properly, we're going to get the top face, and then select it right there. So instead of making 2 coincident mates, you're just making a concentric and a coincident mate, which makes it a lot easier because concentric is pretty much you just select the circles and you're done. Meanwhile, the 2 coincident mates, it's a lot measuring, blah, blah, blah. Okay, we're gonna copy paste this, do the same thing, grab the outside, grab the inside, coincident mate, or not coincident mate, concentric mate, and then coincident mate, this bottom part, this face. You can do whichever face you want. Drag this out, get the inside, and then mate this to this bearing right there. Okay, so now we have a drive module right here. It's pretty much almost done. Only thing we need to add is like some support between these drive plates. So what we're going to do is we're going to right click this, edit part, sketch, circle. We're going to get the outer face, and then do a similar thing that we did with that motor plate. We're going to get this the origin of this fillet, set it to 2 millimeters, features, extruded cut, and then select through all. There. Oh wait, I forgot to do it for the other ones. Okay, now we're going to go back into the sketch. Sorry. Yet another Microsoft Teams notification. Go back into it. Gonna get this other side. Oh, it looks like I did that wrong. Apologies, getting sloppy. Okay. Gonna get this right this time. There we go. Okay. So set this to 2 millimeters. Features. Alright, oh wait, no. Just exit out the component. There. Then we're gonna get some random 12 millimeter aluminum racks. We're gonna copy that, paste it. Now we're just going to check something. Alright, cool. So this doesn't collide. I'm going to get this inside face and leave it right here. Okay, so now that we'll do a second one over on this side. Gonna get this face. You can do this. You can do this inside through hole, or you can do this fillet right here, which I think is a lot easier to do the fillet. You're gonna do the concentric. Make sure this doesn't collide. Okay, we're good. Take this out. Get this face. Coincidentally made it to the inside of this drive plate. Okay, so now we're going to replicate those holes on this side of the drivetrain. Edit part, sketch, circle, select this, 2 millimeters, go to the other side, lock your pencil onto the genesis of this fillet, 2 millimeters, features, ready to cut. Once you start doing this a lot, you get it down to a science, so you're able to do it pretty quickly. Okay, there's our holes. And we'll also replicate the holes to the motor plate we made over here. We'll do right click this and then click edit sketch, not edit component. Now we can see all these standoff stuff. All these standoffs. Set this to 2 millimeters. Make sure you're doing at the genesis of these standoffs right here. Make sure they're fully lined or else they'll come out wonky. Gonna click edit component. Oh, and it looks like we have. Oh wait, no, never mind. We're good. I'm gonna save this just for good measure. You're gonna want to save it every now and then. One, because obviously you don't want to lose all progress, and two, sometimes some errors Solidworks doesn't notice them until you save and reload them. So just to make sure you don't have any errors, you should do that. Okay, so this drive pod is so close to finish. All we have to do is make a spacer over here and then add our belts in, and we'll be done. So yeah, so we'll go File, New, Part. Okay, gonna make a circle, 3 millimeters, and then we'll make another circle outside. We'll make that 5 millimeters, and then we're gonna go back to our drivetrain assembly. We're gonna get a measurement again, measure. This is gonna be a bit hard to get, but get the Sonic hub face and get the inside of this bearing. If you're not able to get the measurement, just I say these measurements out loud anyway, so just like copy what I say for the measurement. So 2.54 millimeters. So we're gonna extrude this by 2.54 millimeters. Okay. Save this. We'll call it have we used motor spacer yet? I don't think we used motor spacer yet. Motor spacer, we'll call it motor spacer. Exit. Go back to our drivetrain assembly, insert, browse, get our motor spacer. Where is it? Oh wait, no, wrong spacer. Sorry. If you get the wrong thing, just before you set it down and left click, just click escape and then it will go away. We're gonna go back here. There we go, motor spacer. We're gonna take the interior or exterior. We're gonna get the bearing, or oops, that is not an acceptable face. We're gonna get this face right here, concentric. Looks like it went down there. Ooh, that's not good. Sometimes when you mate stuff, they kind of like merge into each other and it's hard to get it. Okay, there we go. We got it. So you're going to select that outer face and then you're going to select this inner face down here and coincident mate that. And there we go. And then we'll do it again for the other side. We're going to get, actually this is probably easier than getting this bearing bowl. We'll select the curved side of the shaft. May have merged in, okay. It's over here. We'll move this out a bit. Oh, oops, wrong face. We'll get the Sonic hub face. Coincident. There we go. Okay, so I think we'll add the belts in a later video. I'm going to wrap this tutorial up here. I think next tutorial we'll be able to finally finish this drivetrain, and then later on we'll get into like texturing and coloring your assemblies and all this aesthetic stuff. So yeah.